All right, so we have the organic packet. Yesterday we did the cyclic the cyclic hydrocarbons. Any questions on page 18 or 19?
Did you post the answer key for 1819?
I believe it was on last week's answer keys.
Actually, those are the only 2 pages that aren't.
Really? That's amazing. Let's do them real quick then. What's this?
Methyl cyclohexane.
Good. How about this? One. What's the easy way?
1,3-dimethyl cyclobutane.
There we go. How about this?
Did you add on the butane to the end? Because I didn't see that on the sheet.
That's not a butane.
Oh,
What is that?
sorry, benzene. Did you add on the benzene? Because I just named it cyclobutane.
That's not a benzene.
Oh, phenyl, right?
Yeah, there we go. So phenyl, cyclobutane. Yeah, I put that on there. Done. What's this guy? Either 1-methyl or just methyl. Cyclopropane. This guy.
1,2-dimethyl cyclopentene.
I wish. Close.
Oh, wait. Is that 8? Oh, never mind. It's 1,2-dimethyl cyclohexene.
Close. It's the 1,2 that has a problem.
Is it 3,4-dimethyl cyclohexane?
Yeah.
Hexene.
This has to have the lowest number. So if we went with this being 1, it would be 1, 2, 3, 4, 5. If we go with this being 1, 1, 2, 3, 4. Remember, the double bond gets priority on the number system. A little tricky there. 3.
One, 3,5 trimethyl cyclohexene.
1, 2, 3, 4, 5. Trimethyl cyclohexene. Nice. How about number 4?
Is it
1-ethyl 3-methyl cyclopentane.
There we go. 1-ethyl 3-methyl cyclopentane. How about this guy?
Is it 1,3-diethyl 5-methyl cyclohexene?
I believe so. Cyclohexane. This guy.
One 3-dimethyl cyclopropene.
No, but we start here. 1, 2, 3. Right? That allows us to go 1, 3. We can't go 1, 2 because then we don't include the bond, the double bond. Methyl cyclohexene. So I think we actually named this one on the other side. Well, there we go. Cyclooctane. So we have our octagon, and then we can put the double bond somewhere. Cycloheptene, I believe we did this one yesterday. There we got that, and dimethyl. Cyclopentane. Make it like a house. Or if you are more creative, how do you make it more creative? Instead of these being straight down like they are, like a house, then you can be all like this. Remember, those double bonds can go anywhere you want them to, as long as it doesn't have any other substituent. So keep that in mind. If it does have another substituent, then you got to check these numbers. Cool. All right. Did the aromatic carbon just today. Today we've got the geometric isomers. So we've talked about how we talked about how I can't think of now. Give me 1 second. All right. We talked about how at a double bond you cannot have like rotation, right? So if we take a look, here's this double bond. These cannot rotate because that will break that bond, you know, so they can't rotate. If we take a look, one way to look at this is like this, where after the double bond, both things go in the same direction. That means that these are together, or zusammen, or as we call it, this is cis at the double bond. If we switch that around, notice I have to break these bonds to do this. That's why there are two, that's why these are isomers. They are not the same. I actually had to break and move stuff around to get this. If we take a look, see how now at the double bond, they are going opposites of each other. That is trans. All right, so let's take a look at how that looks within everything. Wow, so behind on the camera. So if I were to redraw this as a stick, I would mess up immediately and have to correct myself. But that right there is the cis. If I were to draw this as trans, that right there would be the trans. See the difference? So if at the double bond, they go off in the same direction, the chain goes off in the same direction, then that's cis. If they go off in opposite directions, then that's trans. Notice you just write cis or trans right in front of each of these. So if we were to take the group, it says hydrocarbon derivatives, functional groups. Oxygen, nitrogen, yes, we view these molecules with the additional elements as derivatives. It is expected that you'll be able to recognize simple functional groups. All right, cool. Let's take a look then. I'm going to put that right there. So somebody give me the name we would give this before learning about cis and trans stuff. What is our longest branch?
Five.
5. Right? So that means it's what? Pent.
Pentene.
Good. Pentene. If we take a look here, somebody want to tell me where that double bonded is, where that we got the number for that ene?
2.
2 works. It's 2 because we want to give chloro the smallest number we can if possible. 1, 2, 3, 4, 5. Okay. So where is the chloro then?
1.
No.
2.
2.
Oh,
2
yeah.
chloro. And where is the fluoro?
3.
3. So we would normally name this 2-chloro, 3-fluoro, 2-pentene. Now we have something a little bit different though. Is this cis or is this trans?
Cis.
This is cis. Take a look. The carbon chain after reaching the double bond keeps going on the same side as it was before. We also notice that the fluorine and the chlorine are both on the same side as well. And can you take a second and draw this as trans on a piece of scrap paper, maybe? How's that? Is that similar to what you have? Leo's Wi-Fi is down. All right.
Hey, sorry, I just got on. I was having trouble getting everything.
No worries, man. It's all right. We record these, right? So you'll be good. Or you could probably pick it up. It's not that hard, I don't think. Did you get this? And what's the only difference that we would do to name this?
Instead of cis, put trans.
You got it. So we would just call this trans 2-chloro, 3-fluoro, 2-pentene. But the fact that that these are 2 different, you can't get those. You can't get those to be the same. It just won't happen that way. You can't get them to be the same without that bond breaking that we talked about. So these are isomers by definition because they have the same formula and they are not the same chemical structure. So that's all it is. We take a look here. Try to draw 1,2-dichloroethene as cis and as trans. Since this is ethene, I suggest that you don't just draw it in stick form. I suggest that you write it out because you only have 2 carbons, right? How's that? For cis, notice that the chlorines are on the same side. For trans, we will do the same thing, except for the chlorines are on the opposite side. Cool, cool. Down here, what would we call this? Actually, let's do this one, D. How many carbons do we have?
Four.
Check again.
Oh, D. 3.
3. So that would be propene. Is it cis or trans? Are the nitro groups, these are called nitro groups?
Wouldn't it be cis?
Yeah, it would be cis. They're on the same side. So this would be cis 1, 2, nitro, propene.
We don't have to put the number next to propane since we know it's the lowest, right?
You got it. Yeah. It's always 1. You could put cis 1, 2, nitro, 1, propene. You might get a few looks, but wouldn't, I mean,
Did
wouldn't,
that for the last page, so I was a bit confused.
yeah. You could, but yeah, you don't have to. Which one, did we do it on one of these?
I think we did it for the ones that had Cl and F attached on the geometric isomers page.
We had to put the number there because that was pentene.
Oh, yeah. Okay. Never mind. That makes sense.
Mhm. But propene, you know, it can't be any different. If they were there, then it would be obviously, we wouldn't even have to worry about cis or trans. If the double bond were here instead, because then you could have full rotation on that bond. Questions? That's it. Go ahead and do 24, page 24 on your own. The answers are up there on like on the calendar date. If you go by the old answer sheet, I think that I messed up on where I put the cis and stuff like that. The cis and trans should always go up front. That must have been a real early answer key or something that I made. Cool. If you have questions, by all means, stick around. If not, have a great day. We will see you tomorrow to discuss function groups. That is the alcohols, the ethers, the ketones, the aldehydes, the esters, carboxylic acids, and other things. You want to try one real quick before, if you're still here? Let's do it. Can you make a pentanol? Well, pentane as well. How many carbons?
5.
Good, 5. 1, 2, 3, 4, 5. Oh, 1, 2, 3, 4, 5, 6. I drew 5 lines, which is 6 carbons. Where is whatever this OL thing located at? On which carbon?
Second.
The second one? And that would be 2-methyl pentane, but this is pentanol. Well, OL at the end tells us that it is an alcohol, and an alcohol is an O bonded to an H. So that would be 2-pentanol. Heptanol, what does hept mean? Or heptanal, what does hept mean?
7.
7. 1, 2, 3, 4, 5, 6, 7. Heptanal, al means aldehyde. You may have heard of formaldehyde before, right? Formaldehyde. Formaldehyde is CH. Is it CH? Yeah. It's a commoner name. Like I believe it's like that. But basically you have a carbon with a double bonded O to it. So on the heptanal, this last carbon here, or it's actually not now considered the first carbon, has a double bonded O on it. And that's what makes it an aldehyde. Let's see, formaldehyde formula. I just want to make sure. Yep, that's right. It's only one carbon. And then 2 hydrogens and then a double bonded O on that carbon. With an aldehyde, it's always a double bonded O on one of the terminating or the primary carbons. And whichever one that is, that becomes the new number 1 carbon. Cool.
So basically, the double bonded O is always so like the first or last carbon, whatever has like CH3, basically.
CH.
Like if,
This would
well,
be CH.
yeah, but like if you before you added the O, it would be CH3, basically.
Yeah.
If you
Yep. So yeah, an aldehyde is basically whenever the double bonded O is on the terminating or the primary carbon. A ketone is whenever it is in the middle. So let's see if we can find a ketone real quick. Here's a ketone. 1, 2, 3, 4, 5. This is pentanone. Since that is not pentanal, we have to identify where that double bonded O is. We know it's not here or here, but it could be at 2 or 3. What is it at? Was it on the second one or the third one?
Second one?
Yep, second one. 1, 2, 2 pentanone. That's it. And that almost ends our unit. We'll go over that a little bit more tomorrow. Friday will be a decent review. And then Wednesday, we'll take any questions you have of the project or anything else. And then next week is just that project and then the test on Friday. Key thing is to make sure that you've done any studying by Wednesday so that you can ask questions on it, since we won't be able to meet until we won't be able to meet Thursday. I'll see if I can find a little review sheet or a review guide or something like that, so that you can look over that for Wednesday or whatnot. I'll give that to you on Friday if I can. Cool. Have a great day. Bye.